Hello YouTube. One of the most significant challenges for modern philosophy is the apparent conflict between our common sense picture of the world and the picture given by our best scientific theories. There are a variety of important philosophical problems that arise from this apparent conflict between science and common sense. So in this video, we're going to look at this apparent conflict in some detail. Before I get into that, I just want to say, if you like my channel, you can support me on Patreon. You can give a one-off donation on PayPal. Additionally, I also offer private tutoring, and send me an email if that is something you'd like to know more about. I also have a Discord where you can discuss these topics with other people. I'll put a link to that in the description. Okay, let's get going. A nice illustration of this apparent conflict is given by Arthur Eddington, who describes sitting down to write a lecture and finding two tables. The first table is the table of common sense. It is permanent, it is coloured, it is substantial. And by substantial, Eddington means that it is composed of matter all the way through with no gaps. The second table is the table as it is described by contemporary science. The scientific table is nearly all empty space, and sparsely scattered within this empty space are electric charges rushing about at great speed. This other table is not coloured. This other table is not permanent. It's like constantly changing. The internal, everything going on inside it is in constant flux. When Eddington puts a piece of paper on the scientific table, it is not supported by continuous matter, but by a series of particles hitting the underside, which maintains the paper at a nearly steady level. So Eddington thinks that there's a conflict between, our common sense view of the table and the table as it is described by science. Moreover, he says, the scientific table is the only table that's really there. The first table, the common sense table, is a kind of illusion. So a nice way of thinking about this is given by Wilfrid Sellars. He describes these two images of the world, what he calls the manifest image and the scientific image. The manifest image is our common sense framework for thinking about the world. It is the world as it is described in everyday practical thought. The scientific image is the world as described by the sciences. It postulates new entities that lie behind the observable phenomena in order to predict and explain what we observe. Now, Sellars was concerned specifically with images of human beings. So in the manifest image, we are viewed as persons, we are conscious beings who have free will and who make decisions on the basis of reasons, and persons are contrasted with mere things, all the objects that populate the environment around us. They do not perform rational actions, they just conform to the laws of nature. In the scientific image, we are biological organisms. We are subject to the same causal laws as everything else. Our behaviour is the result of neurophysiological processes, brain states. So, that's the sort of manifest image and the scientific image of human beings. We can describe the manifest image and the scientific image of many other domains also. So consider colour. In the manifest image, colour is an intrinsic property of the surfaces of objects. So it's like, I look at an object, I see that it is red, and it's got this like special qualitative character to it. In the scientific image, you get things like surface spectral reflectances, wavelengths of light, the refractive indices of various optical media. It's not obvious how colour fits in to that picture. So as Sellars sees it, the scientific image grows out of the manifest image. We start with the manifest image and then we postulate new entities to account for otherwise puzzling aspects of the manifest image. But the scientific image purports to be a complete picture of the world. It purports to tell us the whole truth about how things are, and as such, it is a rival to the manifest image. So, as Sellars puts it, and I quote, "Thus, although methodologically a development within the manifest image, the scientific image presents itself as a rival image, From its point of view, the manifest image on which it rests is an inadequate but pragmatically useful likeness of reality. And of course, the reality is described by the scientific image. Okay, so the scientific image conflicts with the manifest image, but it's worth noting that there can be two kinds of conflict. So first, it may be that science presents an image of the world in which the relevant features of common sense are just not there. So arguably this is the case for moral properties. Moral concepts like goodness, rightness, justice, duty, these don't seem to be used in any contemporary scientific theory. In principle, we might think, we can explain everything that we observe without appealing to these moral properties. Now, if science gives us a complete theory of the relevant domain, then any properties that do not have a useful role in science are thereby threatened, right? So here the conflict arises because the scientific image is taken to be like the complete theory, and this complete theory doesn't have a place for moral properties. So, okay, we got a problem if we believe in moral properties, right? A second kind of conflict is that the scientific image may actively contradict aspects of the manifest image. So Eddington suggests that this is the situation with the common sense table and the scientific table. The common sense table is substantial. It has matter all the way through with no gaps. The scientific table is mostly empty space. Now, I mean, there's a conflict there, even if the scientific image is not treated as a complete theory. We just have seemingly two incompatible descriptions of a table. Again, we're not going to worry too much about this distinction in this video, but it's worth keeping in mind. Obviously, the boundaries between these two types of conflict are kind of vague, and they raise similar issues. So our question then is, how do we react to this conflict between science and common sense? So David Chalmers, in his recent book Reality Plus, suggests that there are four kinds of reactions we might have to this situation. I will add a fifth one that he doesn't mention. It's also worth noting, of course, that we don't need to adopt a universal response. We can take different strategies on a case-by-case basis. But what I want to do here is just give a kind of brief outline of some of these strategies and some of the problems that they face. Okay, so the first strategy, and this is not mentioned by Chalmers, but I think it's worth considering, is to adopt anti-realism about scientific theories. So constructive empiricism, for example. I have a whole video series on scientific realism if you're interested in exploring this debate more. But basically, according to constructive empiricists, scientific theories aim to provide true descriptions of the observable phenomena, but that's all. We can be agnostic about the claims that those theories make beyond what is directly observable, beyond what is perceived by the human senses. So, as far as a constructive empiricist is concerned, science doesn't get at the truth about the underlying structure of reality anyway. Science is a tool. It's a very powerful tool, but it's only a tool for predicting, controlling, and systematizing what we observe, what we directly perceive. So it doesn't matter when there's a conflict between the scientific image and the manifest image. There is actually no reason to believe that Eddington's table is mostly empty space, nor that minds are constituted by law-governed neural processes, nor that there are surface spectral reflectances or wavelengths of light. All of these things, all of these concepts are just useful tools for predicting observations. So one general challenge for this kind of response is that both our scientific theories and our common sense beliefs can account for what we seem to experience, but at the same time, both of them do seem to go beyond our experiences. So, you can take the scientific table and the common sense table as like two hypotheses about our experiences of the table. If the scientific hypothesis is correct, our experience is illusory in some sense. If the common sense hypothesis is correct, the table is just as it seems to be. Now, I mean, so it's one thing to be an anti-realist about science, but the question here would be, well, why endorse the common sense hypothesis? Why assume that the table is substantial all the way through? Indeed, why suppose that there is an external world at all and that objects are as they seem to be? Maybe another way to put this is to ask, what justification is there for believing the manifest image that will not also lead us to belief in the scientific image? The trouble here is that scientific theories are arguably based on the same kinds of evidence and the same kinds of reasoning that we use to form our everyday beliefs about the world. Science differs in that it is more systematic, more rigorous. It uses special methods like peer review, but ultimately the scientific image grows out of the manifest image. And moreover, it actually seems to be better in many ways, in terms of predictive accuracy, consistency, simplicity, explanatory scope. We usually take it that scientific theories perform better than common sense beliefs, at least in these respects. So the thought is that whatever justification there is for believing the manifest image, that's going to apply with even greater force to our scientific hypotheses. So we're going to be led to the scientific image. And so, it's not. So this is one general challenge for sort of using anti-realism to solve the problem, right? If one is trying to use anti-realism in this context, then you might be saying, okay, well, we can believe the manifest image, we can just go with the manifest image because the scientific image is merely a useful tool. But then the question is going to be, well, what grounds are there for believing the manifest image that are not just going to take you to belief in the scientific image? Okay, a second response is elimination. When the manifest image conflicts with the scientific image, the eliminativist abandons those parts of the manifest image. Elimination has occurred many times in the past. In the medieval period, many unusual forms of human behavior or experience were understood in terms of demonic possession. So demons and demonic possession were part of the common sense framework about human beings and their place in the world. Now, with the development of the scientific worldview, with a better understanding of human psychology, we have eliminated demons from our ontology. There are no demons, and there is no demonic possession. The phenomena that were once attributed to these supernatural causes are now explained as being caused by mental illness or sleep paralysis or vitamin deficiencies or the effects of oxygen deprivation or whatever, right? There's all sorts of explanations we now use, but demons ain't one of them. So it seems clear then that the eliminativist strategy is appropriate in at least some cases. There are certain aspects of what we might think of as common sense that are just kind of defective and should be replaced. But of course, philosophers have applied this strategy to a wide range of beliefs that we still currently accept. So aspects of the manifest image that we still currently accept. Since the scientific revolution, philosophers and scientists have suggested that colour and other perceptual qualities do not really exist. They're a kind of illusion, mere appearances in the mind of the perceiver. Galileo sums up this position very nicely when he says, and I quote, "I think that tastes, odours, colours, and so on are no more than mere names, so far as the object in which we place them is concerned, and that they reside only in consciousness. Hence, if the living creature were removed, all these qualities would be wiped away and annihilated." So for Galileo, these sensible qualities, the qualities of perception, perceptible qualities, reside just in our minds. They don't correspond to anything in the external world. And similarly, today you find moral error theorists who deny that moral properties exist. There are eliminativists about free will. There are eliminativists in philosophy of mind who say that beliefs and desires just don't exist, right? This conceptual framework where we explain human behavior in terms of beliefs and desires, that's going to be replaced by advanced neuroscience. Now, a general challenge for eliminativist responses sort of the inverse of the challenge that we saw for the scientific anti-realist. The challenge for anti-realists is to explain what the justification is for believing the manifest image that will not also carry us to belief in the scientific image. And the trouble is that science is, in some sense, an extension of common sense. But that raises the opposite problem for eliminativism, because, well, science is an extension of common sense. So if you say that common sense is just wrong, then it looks like we have undercut the justification for accepting scientific theories. Scientific theories are tested against what we observe. I mean, ultimately, it seems that science has to it has to bottom out in data that is perceived by human senses and understood by human minds. So we observe a bunch of splotches on a graph, and then we have to think about whether or not that confirms the predictions of our theory. Now, if we claim that there are no minds, or that there is no colour, or that nobody ever does anything for reasons, that there are no reasons in general. In other words, if we claim that our common sense image of the world is completely defective, then this undermines our justification for believing that we are observing splotches on a graph, or that splotches on a graph could give us reason to believe anything. So this undermines our justification for accepting scientific theories in the first place. The challenge basically is eliminativism is very often going to be self-defeating. So Sellars himself put the challenge like this. He says, the scientific image cannot replace the manifest without rejecting its own foundation. A related difficulty for the eliminativist strategy concerns how it is that we're supposed to account for the supposedly illusory entities or the illusory experiences. In the case of demonic possession, we can understand how it is that people came to have false beliefs about demons, and so we can sort of think, okay, like if somebody has sleep paralysis, well, yeah, we can explain that within the scientific image. We can explain the hallucination of a demon, and then how that hallucination might have led somebody to believe that there really is a demon there. But now consider something like the case of colour, right? So the eliminativist strategy says there are no colours, right? Nothing in the world is really coloured. Instead, colours are just like subjective responses of perceivers. Colours exist only in the minds of perceivers. They're illusions. But now consider, what about the perceivers themselves, right? So we've seen that colour has no place in our best scientific descriptions of objects, right? So we've taken colour out of those objects and put it in the minds of perceivers. But human perceivers are subject to scientific theory as well. And science provides a description of human beings as biological organisms whose behaviour is the product of brain states. When I open my eyes and I look in front of me and I say, oh, that's a red square, or hey, that's a red car. So science will explain what's going on there by talking about, I don't know, the surface spectral reflectance of the car, wavelengths of light hitting my eyes. Then there's some process going on in my eyes, information down the optic nerve, that causes changes in my brain, etc. Now here's the problem. Just as we do not find colour in the scientific car, or the scientific table, or the scientific hand, or whatever, neither do we find it in the scientific brain. So when you give a scientific description of a brain, there doesn't seem to be any colours in there. Indeed, if you were to open up somebody's head and look at their brain, you don't find any colours in there, right? So again, Sellars summarises this problem. I quote: he says, we have pulled perceptible qualities out of the physical environment and put them into sensations. If we now say that all there really is to sensation is a complex interaction of cerebral particles, then we have taken them out of our world picture altogether. We will have made it unintelligible how things could even appear to be coloured. If the scientific image is the complete story of the world, then we can't account even for the appearance of colour. We can't account even for the illusion of colour. And, well, that seems to be a problem. So that's the challenge. And this problem is going to arise for for other eliminativist strategies as well. So a particularly controversial case concerns eliminativism about consciousness, or eliminativism about phenomenal properties. So, philosophers like Keith Frankish argue that phenomenal consciousness is a kind of illusion. Now, to say that something is an illusion is to say that there are misleading appearances. It appears to be the case that X, but actually there is no X. So, it appears to be the case that there's a demon in my room, but actually there's no demon in my room. Now, the question is, how could there even be the appearance of phenomenal consciousness if there is no phenomenal consciousness? Appearances are phenomenal, surely. That's the objection anyway. Okay, so a third response affirms the autonomy of both the manifest image and the scientific image. So on this response, we retain both the manifest image and the scientific image, and we treat them as autonomous domains. So I suppose we deny really that the scientific image or the manifest image provides a complete picture of the world. When Wilfrid Sellars first sort of presented this conflict, he suggested that it arose from the fact that the scientific image and the manifest image are kind of presenting themselves as complete theories. But on the autonomy response, we might say, well, no, actually, these are just dealing with different domains. So, following Stephen Jay Gould, we might say that science and common sense are non-overlapping magisteria. Gould uses this notion, this non-overlapping magisteria, for describing the relation between science and religion. So, on Gould's view, science and religion are concerned with different areas of inquiry, which means that properly interpreted, they can't conflict. So Gould said that science is concerned with facts, religion is concerned with values. Personally, I find Gould's position here extremely implausible, but perhaps this notion of non-overlapping magisteria might be applied to the relation between science and common sense. So, one way to kind of motivate this is, we might think that, okay, look, just in principle, there are certain common sense beliefs that actually just can't be refuted by scientific inquiry. Let's consider a famous case of the apparent overturning of common sense, the Copernican revolution. So for much of human history, this is the standard story, right? For much of human history, the belief was that, in geocentrism, the Earth is the fixed centre of the cosmos, the sun, stars and planets revolve around the stationary Earth. That's how things perceptually appear. We just see the sun rising in the east, moving through the sky and setting in the west. We just feel immediately and directly that the Earth is still. What could be more obvious than this? But, as it turns out, it's false. The Earth orbits the sun. And the sun is careering through the galaxy. And the galaxy is, we're not the fixed centre of the cosmos. Common sense was refuted. Or was it? Has science really overthrown common sense here? Well, an alternative way to look at this is that science has provided an alternative explanation for our common sense beliefs, but really the common sense beliefs haven't been overthrown. So what people like Galileo established was the relativity of motion. And given the relativity of motion, the claim that the Earth is stationary is actually true, at least from our normal frame of reference. So motion can be measured only relative to some frame of reference or another. Relative to the sun, the Earth is moving at 30 kilometers per second. Relative to the galactic center, the Earth is moving at 250 kilometers per second. Relative to my perspective, right now, the Earth is just still. And all of these motions are sort of real, but none is privileged. So, in fact, then, what was overthrown was not the common sense idea that the Earth is stationary, but the idea of absolute motion. But it's not at all obvious that absolute motion was ever part of common sense. People probably wouldn't have even made a distinction between absolute motion and relative. Like, if you asked just the average layperson in the 1500s about absolute motion and relative motion, I mean, they'd probably just be confused by, they wouldn't know what you were talking about. So that wasn't part of common sense. I mean, so strictly speaking, actually, this story isn't quite accurate because relativity tells us, it's no inertial reference frame is privileged to the Earth. That actually isn't an inertial reference frame. But, still, the sort of crucial part of the original Copernican revolution has it that actually, the Earth is, from our point of view, right, we can still say it's at least still reasonable. It's maybe we should say approximately true that actually, the Earth is just stationary. Again, from our reference frame, from our point of view. So, okay, this is, so this kind of case is, I suppose, is illustrative, perhaps, but it is less clear how this kind of way of reasoning might apply to cases that are currently contentious. A general difficulty for the autonomy response is how we're going to avoid outright contradiction. So take Eddington's tables again. Suppose we claim that there is both the manifest table and the scientific table. There's a table composed of matter all the way through, and there's a table that's mostly empty space, and these tables occupy exactly the same place at exactly the same time. In some sense, indeed, they are the same table. That's very hard to make sense of. So, with motion, we're happy to say, okay, there's no absolute motion. Motion is relative to one's frame of reference. How does that extend to something like Eddington's tables? I mean, what should we say here? That relative to normal human perception, the table is composed of matter all the way through, while relative to certain scientific instruments, the table is mostly empty space? I mean, we just seem to be saying that the table is both like wholly material and it's mostly empty space, and that just looks like a contradiction. Moreover, it's not at all obvious how we should even define the relevant reference frames here. After all, we can't draw a strict distinction between human perception and scientific instruments because scientific instruments are used by human perceivers. We can draw conclusions from them only through perceiving the data that they produce. So basically, with something like the relativity of motion, firstly, there's no contradiction in attributing different velocities from different reference frames. And secondly, there are well-defined reference frames. And neither of these seem to be the case for Eddington's tables. And similar problems are going to arise for for lots of other cases as well. So so I take free will, for instance. Let's say there's some reference frame from which human behaviour is fully determined. So the facts about the fundamental particles in conjunction with the laws of physics entail exactly one unique future. Everything we do is fixed in advance, and we could not possibly do otherwise. Okay, human behaviour is fully determined. Well, it's no use saying that, from an everyday perspective, the future is open and there are alternative possibilities. I mean, that can at best be an expression of our epistemic limitations. So yeah, I mean, we don't know all of the facts about the physical particles, and our computational abilities are limited, so we can't predict exactly what the future will hold, but it remains the case that if the universe is deterministic, there's only one way it can go. So if there's like a common sense belief that that we have like free will in the sense that there are many possibilities open to us, well, it's not clear how we can use the autonomy response here. So one option for those who take this autonomy line is to deny that the manifest image is really a theory in the way that scientific theories are. So perhaps we could say something like this. We might argue in this kind of way. We might say, well, scientific theories, they aim to provide descriptions of the world, and they're true or false in virtue of whether or not they correspond to the relevant states of affairs in the world. But the manifest image isn't in the business of giving descriptions, or at least it isn't primarily in the business of giving descriptions. What is the manifest image for? What do we do with the manifest image? Well, we do all sorts of things. We make promises, we tell jokes, we confide our feelings in other people, we sympathise and empathise, we make threats, We pressure and manipulate other people. We build houses, we drive cars, we prepare food, we pursue professional careers, we make YouTube videos. The manifest image is tied up with a whole variety of social practices. And so, unlike science, it is not to be evaluated in terms of whether it allows us to predict and explain the results of carefully controlled observations. When we conceive of ourselves as having free will, or as having consciousness, or as being subject to moral norms, or as interacting with ordinary macroscopic objects like tables, we're not trying to provide a theory, we're not trying to give descriptions that might correspond or fail to correspond to states of affairs as described by science. So that's maybe one thought here, one way of pursuing the autonomy line. So, I mean, perhaps this provides a kind of justification for the manifest image, but there is an obvious worry here, which is, although it's true that there are many things that we do with the manifest image, and that the manifest image is tied up with various social practices, it still seems that one of the things the manifest image does, and actually one of the important things it does, is give descriptions of the world. And indeed, the descriptions that the manifest image gives are like also connected to the sort of practices that it is involved in. So, like, when I make a promise and I thereby take myself to be under an obligation, it seems like this involves the belief that promises generate moral obligations. So I'm believing in moral obligations. So, like, okay, perhaps the manifest image is justified for reasons beyond descriptive accuracy, but I mean, on this way of approaching the autonomy response, we still seem to be saying that the manifest image is just false, and we might be a bit worried about claiming that the manifest image is just false. It turns out that all of these things that we do with the manifest image are sort of based on false presuppositions. Okay then, a fourth response is identification. On this approach, various aspects of the manifest image are treated as just identical to aspects of the scientific image. So we deny that there is actually any conflict. For example, the scientific table just is the manifest table. The table is revealed in a particular way through perception, and then science reveals more of its properties, including whatever properties explain the way that it appears in perception. A classic example of identification is the identification of water with H2O. So water seems to be a single thing, and historically it was long thought that water was a fundamental element, indivisible into other types of things. Now, on discovering that water was composed of hydrogen and oxygen, we didn't conclude that therefore water does not exist, or indeed that there was any kind of conflict between our common sense view of water and the scientific view of water. No, we just discovered that water is identical to H2O. So the point is that when we used the word water in the past, we were tracking H2O, even though we didn't always know that water was H2O. So we used the word water to describe, the liquid in this glass, to describe the liquid that falls from the sky, to describe the liquid that fills oceans and rivers. And then we, did some investigation. It turns out this liquid is H2O. So water just is H2O. We have identified an aspect of the manifest image with an aspect of the scientific image. So how might this apply to more philosophically contentious cases? Well, take for instance moral properties. There are some philosophers who argue that moral properties just are certain types of natural properties. So moral goodness is whatever property or set of properties is associated in the right kind of way with our use of terms like good and right. One naive option here is to say that moral goodness is just pleasure. When I say it's a naive option, I mean it's like it's simple. It's just a very simple, simple identification. Goodness is just pleasure. So goodness is just pleasure, and what you ought to do is maximize pleasure. I call it naive just because most moral naturalists have somewhat more sophisticated views than this, but this is illustrative of the strategy, right? So the assumption here is that pleasure can be described scientifically, maybe in terms of states of the brain or associated forms of behavior or whatever. And suppose then that we can, give an analysis of the meaning of moral terms, right? The meaning of concepts like good or right. And we can sort of show that actually these concepts refer to particular states which turn out to be states of pleasure. So we might show that, when people use terms like good or right, what's actually what causes them to use those terms are states of pleasure. So in the same way that we use the term water in response to a particular kind of substance, similarly we use the term good in response to a particular kind of brain state or a particular kind of behavior. And so then if pleasure has a place in the scientific image, and if goodness is just pleasure, then we have identified goodness with an aspect of the scientific image. So consider this photograph. There are many ways that I could describe this photograph. I could describe it as an image of John Cage. But of course this image is made up of pixels. So I could similarly describe each pixel that composes the image plus its location. So I could say, here is a white pixel, next to it is a grey pixel, next to it is a black pixel, and so on. It would take me a while to do that, but I could do that. And this second description, this pixel description, does not explicitly say anything about John Cage. Even so, the fact that this is an image of John Cage, in some sense, is contained within the pixel description, or it follows from the pixel description, in some sense. And so this is because if you have exactly the same pixels in exactly the same arrangement as shown here, then you have the same image. You have an image of John Cage. So we can see that there are two different ways to describe the same thing, two different perspectives on the same thing. We have, just a straightforward description like this is an image of John Cage, and then we have the pixel description. And really they're just describing the same thing in different ways. And so we might say the same thing about the relation between common sense and science. Science does not explicitly describe the manifest world. It doesn't, in general at least, it doesn't use the terms and concepts of common sense. Physics doesn't talk about tables or hands or mountains or whatever else. But even so, the manifest image may in some sense be implicit in the scientific image, because the right arrangement of particles that are described by physics, obeying the laws explicitly described by physics, will realise what we call tables or hands or particles. Notice that here the difference between the two types of conflict that we saw earlier becomes particularly important. Where scientific theories outright contradict common sense, identification is going to be implausible. But where scientific theories simply fail to make use of common sense concepts, we might take it that both science and common sense are describing the same thing in different ways. Okay, so the general challenge for the identification approach is that this sort of smooth reduction of concepts from the manifest image to concepts of the scientific image very rarely, if ever, occurs. So, the assumption of identification is that we're using different concepts to describe the same thing. We're just describing the same thing in different ways. But one issue here is that usually there's going to be sort of content that fails to be translated. So take the case of moral properties again. One challenge to attempts to reduce moral properties to the properties described by science is that this is going to just eliminate something crucial to morality, namely normativity. So this is this is a classic example. This is a classic objection to moral naturalism. Is look, moral facts tell us what we ought to do. They tell us what we have reason to do. Morality has this kind of special authority over us in that it's supposed to provide us with reasons for action that are independent of our personal desires and goals. So even if I want to own slaves, and it would benefit me to own slaves, still I ought not to own slaves. I morally ought not to own slaves. And the thought is, it's hard to see how this kind of categorical normativity, these sorts of reasons for action that are independent of desires, it's hard to see how that's going to be provided by science. It's hard to see how that can be identified with any natural property. So, it's going to be a fact that a person is in pleasure or is in pain. So, let's say I'm performing an action that causes verity pain. Okay, fine. Well, that can be described scientifically, or at least we'll assume for the sake of this example that it can be described scientifically. So, okay, I'm performing an action that's causing verity pain. That can be identified with a scientific image. But how can this fact in itself, just in itself, how can that give me any reason to do anything? Okay, so I'm performing an action that causes verity pain, and I say, okay, well, I want to. I want to perform this action. And then, well, you're going to want to say, no, but you ought not to do it. It's morally wrong. It's morally wrong. Even though it's something you maybe desire to do, you still ought not to do it. The question is, where's that ought coming from? How does that ought fit into the natural world? And so the worry is that if we just try to identify pleasure with goodness and pain with badness, then we're going to lose content, right? We're going to fail to capture normativity. That's, again, this is a big debate. Moral naturalists have responses to this, but that's the worry. A second concern here is that even in classic examples of identification, we actually find on closer inspection a lot of wrinkles. So take the discovery that water is H2O. Okay, pretty much everybody's going to accept the identity statement, water equals H2O. This is a standard example that philosophers use of a successful reduction or identification of a manifest concept with the concept of a scientific theory. So the identification, water with H2O. But arguably, we can only affirm this identity after making a host of idealizations. I talk about this in a bit more detail in my video, Water is not H2O, which I will link in the comments. So very briefly, here are some wrinkles, let's say, some concerns. First, there are other isotopes of hydrogen and oxygen. So there's deuterium and tritium, so there's D2O and T2O. Arguably, these also count as water. And then similarly, you get different isotopes of oxygen. So it's not just oxygen 16, oxygen 17, oxygen 18 as well. So there's actually all of these different isotopes of the relevant molecules, not just H2O. Second, due to chemical bonding of water, in any sample of water, there will not just be a jumble of H2O molecules, but there's going to be many hydrogen-bonded polymers of the H2O molecule. Third, due to self-ionization of water, there is in any sample of water not just H2O, but ionic forms such as hydron, hydronium, and hydroxide, plus polymers of these. Water arguably is not going to smoothly reduce to H2O, right? When we say water is H2O, that's arguably a simplification, right? I mean, it's like if you just had... So water, the manifest kind of water, isn't just like a set of H2O molecules. And a single H2O molecule, I mean, would that be water? Well, actually, that's less obvious. Doesn't have any of the relevant properties of water. And it turns out that when you look at water, you can't just say that that's just like this, jumble of H2O molecules. So, yes, it turns out that reality arguably is much more complex than the identification response suggests. Okay, the final response is Reconstruction. In Reconstruction, we acknowledge that the manifest image and the scientific image are at odds, but then we remake the manifest image. We remake it in order to bring it in line with the scientific image. So this is a kind of conceptual engineering. The manifest image contains, we have all these concepts for thinking about ourselves and the world, and then when there's a conflict with the scientific image, we revise the manifest concepts. Arguably, Reconstruction is what has actually occurred in the case of solidity. So we may once have defined solidity in terms of substantiality, as Eddington would put it. So solidity is a matter of, solidity involves matter all the way through. Today, we don't think of solidity in those terms, but we do still classify some objects as solid and some as not. There's still a relevant difference between ice and water. So, Eddington enters his room, he encounters a solid table. The table doesn't have all the properties that might once have been attributed to it. It's not solid in the sense that it's substantial all the way through, but it's still solid in some broader sense. So there are various ways of defining solidity. There are various concepts of solidity, and it's partly up to us which of those concepts we deploy. David Chalmers suggests that a useful strategy for Reconstruction is functionalism. So I said that there's a relevant difference between the things that we usually label solid, such as ice, and things that are not usually labelled solid, such as water. So what is this difference? Well, solid things are the things that we call solid are those that are kind of rigid and they resist penetration by other objects. So it's like I have a table in front of me, I try to put my hand through the table and I just can't, right? Whereas, if I have a glass of water, I can put my finger through the water. I can't just put it through the table. So we have there's this difference between these things. The table resists my finger, the water does not. Now, so we might say, okay, well, that's just what solidity is, right? Solidity is a matter of resistance to penetration by other objects. So what's happened here is that instead of thinking of solidity as an intrinsic property of objects, we now think of solidity as a matter of how an object interacts with other objects. We have a functionalism about solidity. A functionalist account of some property will define the property in terms of the role that it plays within some broader system. So solid objects are those that resist penetration by other objects. Any object that plays this role is solid. Its intrinsic properties, its internal constitution are irrelevant. We just have to look at how the object relates to other objects. So with Eddington's table, well, Eddington's sort of solid with a capital S table, the matter all the way through, yeah, that table doesn't exist. But so what? The functionally solid table does exist, and the functionally solid table is entirely compatible with the story given by science. Indeed, the scientific story explains exactly how it is that the table plays the solidity role. It explains exactly how it is that the table resists penetration. So we have a kind of, this is the picture, right? In the original manifest image, we think of things as having various intrinsic properties, and these intrinsic properties explain their relations to other things. The table resists penetration by other objects. How does it do this? Well, because it's substantial. It's matter all the way through, and the solidity of the table consists in its substantiality. But then, in the reconstructed manifest image, we no longer care about intrinsic properties. Only the functional properties matter. The relations that various objects bear to other objects. Resistance to penetration is just what solidity is. Similarly, with colour, in the original manifest image, colour is an intrinsic property of the surfaces of objects, right? Like human beings, we open our eyes and we just kind of passively receive the colours that are out there in the world. In the reconstructed manifest image, maybe we say, well, colour is like, a power within the object to produce particular sensations in us. So, there are certain types of surfaces that for normal observers in normal conditions will produce sensations of red. And that's just what redness is. It's just, like as long as an object has that kind of surface, as long as the object is such that it produces a particular reaction in us, that object counts as red. So we're now thinking of redness not as an intrinsic property of an object, but in terms of the role that the object plays within some system, namely the role that it, like how it interacts with us. So Reconstruction may be sort of connected to the other responses that we saw. In particular, it's a bit unclear where to draw the line between identification and reconstruction, because by reconstructing solidity, we have now identified solidity with some aspect of the scientific image. Like, we can't identify intrinsic solidity with the scientific image, so we reconstruct the concept into functional solidity. But functional solidity, or so the argument goes, can be identified with the scientific image, because the scientific image provides a straightforward account of how objects resist penetration by other objects. So the general danger of reconstruction is that it risks changing the subject. So consider, for instance, compatibilist analyses of free will. Compatibilists say that free will is compatible with determinism. In order to defend this claim, compatibilists will propose their own analyses of what exactly free will is. And we can see this as a reconstructive proposal. So the question is, what is free will? Well, that phrase is hard to define. In everyday usage, people probably take it to mean that they have some special control over their decisions, that they could make different decisions, that there are a variety of future paths open to them, that they choose which path to take. So, when facing a fork in the road, it's entirely up to me which way I go, and I could go either way. It's an open future, and that is incompatible with determinism. If determinism is true, actually, I'm going to go one way and one way only. But compatibilists will say, no, you can still have free will. Now, I mean, when they say that we can still have free will, they don't mean that it's compatible with determinism, that there are various different possible futures open to us. Instead, they'll say something like, well, look, there are various capacities that human beings have that distinguish them from other creatures, and these capacities are important to us. For example, human beings have the ability to reflect on their decisions. So, I make a decision and I can think, was that the right thing to do? Human beings have not, we don't just have impulses or instincts, we also have these kind of higher order desires. So, like, I can see a chocolate cake and I can desire to eat the chocolate cake. I can feel the impulse to eat the chocolate cake. But then I can say, no, wait, don't eat the chocolate cake. It's not healthy. And I might then act on that second order desire. And so the compatibilist might say, well, as long as you've got that, what more do you want? That's enough for free will. But the obvious objection to this kind of thing is to say, well, isn't this just changing the subject? I mean, what we're interested in is whether there are alternative possibilities open to us. If we don't have that, we don't have free will, by definition. When I was working as a teaching assistant at university, I found it very difficult to teach compatibilism, because many students would they would insist that, what the compatibilist is saying, that's just not what is meant by free will. To most of these students, compatibilism seemed to be an obvious contradiction in terms. It was as if we were talking about square circles. To say that you could have free will even if the world is determined, that's just incoherent. And so, I mean, the general point then is, like, for any proposed reconstruction of a manifest image concept, there's a natural reaction is to say, well, so what? If you've reconstructed the concept, then you're just not talking about the concept that I care about. The new concept isn't the concept that I was interested in. When you revise the meaning of a concept, you change the concept. And that means that you change the subject, right? You're just not talking about the thing I was talking about. So if there's some concept that is creating a philosophical puzzle, you don't solve the puzzle by revising the concept. if you revise the concept, you've just ignored the puzzle and you're talking about something else. And so the challenge for the Reconstruction response will be to show that there is enough continuity between the reconstructed concept and the original concept that we can say that the reconstructed concept actually is, it is like addressing the same issue. It is talking about the same topic, and it is solving the puzzle. Okay, well, that is the end of that. So I hope you found that interesting. I will say goodbye. See you in the next video.